I have always been super passionate about data, and I know that sounds really weird to say, but it's always been something that I feel like if you're going to go and make a business case for anything, that you should have some hard facts to back you up. And for me, that's data. When I started the program, I was a senior business analyst at Express Scripts. From then, I actually moved into Accenture. So Facebook was my client. I actually worked as a data engineer there for about a year. After that, I actually got a role as a data science consultant. So I have successfully, I think what I was looking for in this program actually came true for me, was really getting that title of a data scientist. It's not a challenge that you can't overcome. Every single month we get a new class and I go into a panic, and yes, it's always a shock. It's always a, can I do this? And you're always going to be doubting yourself, but there's so many people around you that believe in you that it's going to be really difficult for you to actually fail. I didn't expect to make as many friends as I have made in this program. I thought I was just going to be like me, kind of on my lonesome on the side, like trying to figure out how to answer all my homework questions by myself. But somehow, like, there's just so much camaraderie. It's kind of amazing. I would say hit the submit button, because you are not going to get better professors, a better community than what we have here.
Good morning from beautiful Ann Arbor, Michigan, and welcome from wherever you are in the world. My name is Amy Humkus Hayes, and I'm the Associate Director of Online Programs and the Strategic Advisor to the Leadership Team on Online Programs and Digital Content here in the University of Michigan School of Information. We will spend about the next hour together or so talking all about our Master of Applied Data Science degree, which we are very excited about in the School of Information. It's our most recent degree, so it's the one that we've launched just started in 2019, and it's already our largest degree. So we have many positive things to say about our MADS experience, while at the same time remaining transparent with all of you about what to expect as you navigate the application process, and ultimately what we hope is your admission and entrance into the MADS program. I am very pleased to be joined with three of our esteemed faculty members in the School of Information today, who all teach both in our residential programs and in our maths degree. So I'm going to go ahead and let each of them introduce themselves, and then I'll talk a little bit more about how we're going to spend this time together. Kevin, can you go ahead and start us off?
Sure. Thanks, Amy. Hi, I'm Kevyn Collins-Thompson. My background is in computer science. My PhD from Carnegie Mellon School of Computer Science. I worked for a number of years in industry, industrial research, Microsoft research, and then I came to Michigan about 8 years ago. I've been loving it at Michigan, and I love working with the students here. I've been teaching in the maths program since the beginning. I helped design some of the aspects of the program, and I mainly teach machine learning courses, some of the machine learning courses anyway, and also I lead the Milestone 2 project, which is a major project that occurs in the middle of the degree. So looking forward to getting your questions and talking more about the program.
Thank you, Kevin. Elle?
Hi, I'm Dr. Elle O'Brien. I'm a lecturer and research investigator at the School of Information. My background is in biomedical research with a quantitative aspect to it. And so I've been very enthusiastic about, joining the MADS faculty where I can, advise a lot of student projects, and some of them are really quite exciting. And I have the great fortune of teaching the Capstone, which is kind of like a little bit like a master's thesis. It's like a final, very applied project that you do, which is, designed to be a portfolio piece that you can take with you to show employers and kind of make your mark in the data science community. So I'm happy to take any questions about that, and I'm looking forward to hearing more of your questions.
Thank you. And finally, Paramveer?
Thanks, Amy. Hi, everyone. My name is Paramveer Dhillon, and I'm an assistant professor in the School of Information. I'm also a computer scientist by training, and my research interests are in machine learning, computational social science, and information systems. And I got my PhD from the University of Pennsylvania. Coincidentally, I also joined the University of Michigan School of Information in 2019, the same time as the MADS program started. So whether it was correlation or causation, I leave it up to you to decide. But I really enjoy teaching in the MADS program, and I teach Introduction to Deep Learning, Data Mining 1, and Data Mining 2. And I really enjoy interacting with all the MAD students, and I hope to answer many of your questions or your thoughts, which you might have before you hit submit on your application. Thank you.
Thank you so much. So as I indicated, I am humbled to be here with three esteemed faculty colleagues, all researchers and faculty in the School of Information that are doing really significant research in addition to teaching wonderful maths courses, some of our most complicated and special, both our machine learning sequence as well as our project-based courses. So right now, we want to turn it over to all of you to do some Q&A for about the next hour or so we can answer all of your questions about the MADS program. There are no questions that are off limits, so we would welcome you to chat all of your questions to us using the chat function in the YouTube live event, so we can go ahead and answer some of your most burning questions about what it means to be a student in the MADS degree, how to navigate our curriculum, what our project-based courses are like, how we've conceived of and act on what it means to teach end-to-end data science, as well as if you have any burning application questions that you want to have answered as we spend some time together. I should mention that in an instance where you have a very specific question that you would like answered, you are welcome to post it in the chat. If we don't get to it today, you are also always welcome to email umsi.mads@umich.edu, and we will certainly respond to your email questions as well. So for now, I would, and again, invite all of you to post your questions in the chat so we can have some great discussion and meaningful discussion with our faculty contributors today. While I wait for some questions, I have some questions that I know are common amongst applicants in the MADS degree, and that is around the kinds of data science that we're teaching. So I'm going to go ahead and start with you, Paramveer, because you do teach our deep learning course, for example, and in fact, created it. And as you know, you and I, but particularly you, often get questions about what are we teaching in that course, right? How are we preparing our students for really cutting edge data science practice in any number of industries? So can you tell us a little bit about the aspects of that course that you're most excited about?
Yeah. So yeah, first of all, I must say that I think like our maths program is probably one of the only few programs that are out there offered by any university, which covers the entire pipeline of data science. From very beginning, from how to be a data scientist to developing the toolbox of a data scientist, that is learning about data mining, machine learning, deep learning, natural language processing, and then even learning causal inference and experimental design, some of those things which are not covered in any data science course. And then finally, also talking about societal impact of AI, data science for social good and AI ethics and so on. So we cover the entire pipeline that you need in today's world in order to succeed as a data scientist. And in that pipeline, I teach some of the methods courses, like the Introduction to Deep Learning course is a course that I developed, and the two data mining courses are which I teach, though they were not developed by me. So let me tell you a little bit about the Introduction to Deep Learning course. So as we all know, neural networks or like deep learning models, they are a kind of machine learning models. They're a subset of machine learning models which have shown staggering improvements in many high dimensional classification tasks. Like, for example, in natural language processing application, like doing Google Translate, like you could see the quality of Google Translate from 10 years ago to today. Or you could see how well the image recognition on your phone works. And you would be amazed how good these algorithms are compared to 10 years ago. And the main reason they are so good is because they are powered by some of these neural network-based models, which are in simplest terms, machine learning models on steroids. Right? So they have lots of parameters and like they're really complex models, but there's a very methodical and systematic way to understand these things. And in this course, we try to do that in the Introduction to Deep Learning course. So we start with the very basics of neural networks, how they are different than traditional machine learning models, how to train them, and how to evaluate them. Then for the next 3 weeks, we focus on specific types, specific architectures of neural networks. So for example, in week 2, we focus on convolutional neural networks, which have shown staggering improvements for image classification tasks. Okay. Then in week 3, we study recurrent neural networks, which have been very successful for natural language processing tasks. So for example, for machine translation or recognizing whether somebody is a person, organization, or location. And you can see on, all of you spend lots of time on Google, I'm sure, and you could see how well some of these systems work. They could figure out, which entity you are searching for, or like what's the exact meaning of a thing that you search for on Google, what's the relevance of that, and so on. And then in the final week, we study this new technique called GANs, or Generative Adversarial Networks, which have been one of the coolest things to come out of deep learning in the last 7-8 years. So essentially what these models do is they are generative models. So you could use them to generate anything from art to like fake AIs, or deep fakes as they are called these days. So they are like both benefits as well as perils of some of these approaches, which I hope to cover in this course, and I discuss that with my students in my office hours. Yeah, so that's it, Amy. Thanks.
Thank you, Paramveer. What I loved about your explanation is you contextualized how we're teaching a course like deep learning in the larger applied program. And we do really emphasize the applied nature of our master's degree in data science, as opposed to some of our competitor programs, for example, where they take a more theoretical approach to teaching data science. Elle, you, of course, are deeply involved in the application of data science in our Capstone course, which is really our culminating learning experience for our students. Can you talk a little bit more about how you define applied in the Master of Applied Data Science and how you see that show up in the Capstone?
Yeah. So, up until the point of the capstone, although there are a couple project-based classes before that where people might start to really whet their appetite on what it's like to work on, a full stack data science problem where they're involved from conceiving the idea to carrying out the analyses to interpreting and presenting it. You do a lot of topics that you cover, and everything is taught, very much through coding and through, working on the problems yourself. But I think things become very surprising, and there's something that you just can't teach. You just have to do it to understand of what it's like to really go get your data set, discover all of the problems that are in your data set, all of the inconsistencies and the bad labeling and the ways that you need to clean it. And then you have to figure out your analysis, realize that the type of neural network that you set up, it actually, nothing's coming out of it and you can't understand why, and you've got to debug it. And then you've got a couple teammates and you're all trying to work on this together. And it turns out collaborating on, code and models is actually quite difficult sometimes. And so the capstone is really the place where all of those little pieces that you've picked up meet. And then, for some people, it's really, the first time that they're getting to see a real data set, and they'll often team up. We've had some great collaborations. We had a team collaborate with the Michigan ACLU to look at voter data. We've had a team work with NOAA, the National Oceanography Association. I think that's it. I'm possibly butchering it, but and they'll get these very real data sets that, really force you to put in all of, the knowledge you've learned, but also develop some intuition and, a sense of what it's like to be a craftsperson, making something that has value out of these imperfect and difficult pieces. So it's really fun for me to watch everybody, go through those stages of, okay, now I've got to debug my neural network. Now I've got to understand what business impact this value has, this result has. So it's a pretty, exciting kind of sandbox course where, there's a lot of self-exploration, but you're never too far from a faculty member who can jump in and give you a little guidance or help you keep on track.
What I love about your answer, Elle, is that not only are you doing a great job of defining the applied in our applied data science degree, but you're also talking about the real world applicability of the projects that our students are doing, along with the mentorship that they're getting from professionals like you, who not only have great scholarly and teaching experience, but also have great kind of real world experience, quote unquote, to offer as well. And so, Kevin, similarly, you've been invested in both doing computer science and data science in industry and in academia. How do you define applied, and how does that show up in the courses that you teach in the maths degree?
Oh, great question, Amy. Yes. I spent probably a total of, between 10 and 15 years in industry. Not all of that was I spent 5 years as a research scientist at Microsoft Research, embedded with lots of fascinating problems. My expertise is in search and recommender systems. I've done a lot of work in commercial search engines, for example. And I guess, to me, the applied part involves not just the understanding of sort of not just working with real world data sets, and I know my view is shared by broadly within the program by everybody in the program, that it's not just about the data, it's about people as well. So how is this technology going to be applied with people? And so when you're deciding on a project and deciding what machine learning problem to solve, what things you're going to optimize, it's important to learn how to ask the right questions about who's going to be using your system, what are the implications of a failure, what are the real implications of a failure, and all those things have to inform your design of a machine learning pipeline to solve a particular problem. So I would say that the applied aspect is all about working on real problems with real data, and it's also about working with real people.
Thank you. I think that's incredibly well put, Kevin. And in fact, not only are you working on data problems that we hope have a positive impact in society, however that's defined, but you're also engaged in a community of people in the maths degree. And our community, of course, is growing, is international because we accept students from all over the world. In fact, one of my favorite things to say is that we have at least a math student on every continent but Antarctica. So that's the only place that we're missing one as of now. And so we have this really fantastic community. Can you talk a little bit, Kevin, about what it's meant to you to work with these diverse students from all over the world?
I have to say it's been a fantastic experience. You know, I've taught data science courses for a while, quite many, 10 years. And MADS is definitely my favorite student cohort. I mean, I like all my students, but the MADS cohort is particularly impressive for their diversity, for their motivation, for their depth of experience, and an incredible wide range of backgrounds I mean, you name it, in government, in corporate world, in nonprofits. I mean, it just, and I see this, in the Milestone 2 course that I run, because that involves, a large degree of customizing the project to your career goals. And so I love it. I think we had office hours for Milestone 2. So I set up big blocks of time during the week where teams would meet with me one-on-one. And some of those meetings, there was one team that had people on like 3 different continents. so setting up the time zones sometimes is a bit of a challenge, but students are, it's an amazing community of people with an incredible diversity and depth of perspectives on data science. I think one of the things that I see as an instructor, the students, they get a lot out of the courses, but they also get a tremendous amount out of their time with other students in the program. And by the time they leave the MADS program, they've been able to meet and connect with so many different fascinating people. I think that's a huge, huge bonus of the program as well.
Thank you. Paramveer, same question to you. Tell me a little bit about your experience teaching in the MADS degree. What do you see in so much as kind of who shows up to your classes and what they're interested in, how they're navigating their experiences?
Thanks, Amy, for the question. So I would totally echo what Kevin just said. I think I'm just amazed that I have my office hours. Sometimes I hold my office hours in morning US times, US Eastern time. Sometimes I do it in evening. So for example, today evening for one of the courses that I'm teaching data mining to, I have my office hours at 8:30 p.m. And you would be amazed that there are people from almost different continents joining to ask questions. There are people from Eastern time zone, there are people from Pacific, there are people from Asia, and then some people from Europe. So it's just amazing that, as they say, that the geographical borders have shrunk due to internet. This is the best example of that. And it's good to see that, people in their offices in Hong Kong, taking MADS courses and, asking questions about assignments. It's just amazing, how things work. And I really enjoy, this global cohort of MADS that, that we built semester after semester. And how different perspectives that they bring on data science and how data science is important for their careers and their interests. So I also am very active on Slack, because Slack is one of the main means that instructors interact with the students other than office hours. And it's just amazing, how much activity there is. I would say, when it's morning time in Asia and evening time here, there would be questions, and then there would be lots of chit chat among students, as well as GSIs and instructors also answer questions. So it's just amazing how the variety of questions and perspectives we get, and how much stimulating discussions there are just among students, which is just amazing to see, how much they are thinking about these problems, how deeply they want to be involved in the course material, and so on. Yeah.
Thank you. I agree. And I appreciate you mentioning our Slack workspace, which is one of the communication vehicles that we use in the maths degree, that is time zone agnostic, right? That anyone can be on at any time around the world. And that is divided both into our general channel, our interest channel, for example, things like data science ethics, math for data science, and then of course, all of our course channels where students can interact with and engage their peers in addition to our instructional teams, getting both in real time or close to in real time support. So Elle, we've been talking a lot about the diversity of the students that are in the maths degree and both where they've come from in addition to where they're going. And we had a great question come in from someone who asked if this degree is applicable to industries like pharmaceuticals or biomed. So could you talk a little bit about your view on the answer to that question?
Yeah, definitely. I really see the ability to work on, big data and machine learning is going to be pretty transformative in a lot, like most biotech companies, I feel like are investing in their, data science and machine learning infrastructure. And so you can make yourself a very valuable commodity if you have some expertise already in that area, plus the understanding of, not just the statistics of data science, but also like, how do I build a data science pipeline? How do I work with a team, that's got some engineering aspects to it too. And, we had we do have some capstones that are, biomedical. We had one recently that was looking at explainable AI. So the idea that, there are models that are easy to interpret, but they sometimes are underperformed by models that are more complex but challenging to interpret. And how do you build trust by clinicians in those, more difficult to understand models? How do you get them, what do they need to see to develop, comfort and trust in those models enough that they could make a clinical difference? And I happen to know that at least one of the authors on that project is now working in a healthcare company. So, there's certainly a contingent of that present. And I feel like, it's a very needed skill set in the area, and there's going to be no shortage of cool things to work on there in the next few decades.
Absolutely. And thank you for giving us such great examples of where we're already seeing that show up in the degree. I mean, something that you mentioned that I think is really important to reiterate is that we have a curriculum that is steadfast in so much as what we believe is kind of the best way to teach data science, but we still have these the capstone and milestone courses where then you can take that approach and apply it within a specific industry or field. So not only are you getting kind of the broad data science education that we anticipate and expect you would need to be successful, but you're also able to go deep within specific areas, either in courses and or in projects. So speaking of where and how data science is showing up in the world, Paramveer, we did get someone who asked a very specific question about libraries that we use in maths. And so I was hoping that both you and Kevin could speak to this. Can you tell us, for example, are we using TensorFlow? Are we using PyTorch, right? How are the libraries showing up?
Yeah, awesome. Thanks, Amy, and a great question. So Python has become the de facto standard language for data science. So all our courses, they use Python and via Jupyter notebooks, so that you could interactively execute the notebooks via like this Jupyter notebook platform. And the main libraries that we use. So of course, we use some of the standard ones like NumPy and sklearn and scikit-learn and pandas for data manipulation and so on. And then for some of the courses like, which for neural network based models, we use PyTorch, and the reason we chose PyTorch over TensorFlow is, TensorFlow has found more widespread adoption in the more enterprise scenarios. If you want to build a deployable product, like a deep learning product, then you should use TensorFlow, because there's just a lot of boilerplate code that goes into get something running. Whereas PyTorch abstracts many of those things away, and the code is nice and simple and clean, right? And in fact, to even make things simpler, because neural networks are new species, and so to say, of machine learning models, and becomes difficult to like learn them from scratch in a space of 1 month to scaffold some of that. So in my deep learning course, what we do is like we give you a bunch of starter code, in PyTorch, and then we ask you to insert a few lines of code or to change some of the architectural architectures of some of these neural network models and see how their performance changes, and then try to interpret, why is this change happening? Because as Elle also mentioned, like some of these models are really complex, so interpretability is not their forte. So we need to be able to poke into them and see like poke into them using probes and see like how and why they're performing something when they're performing. We are not merely satisfied with the vanilla accuracy numbers going up. So, and we reflect that in our courses, like in the deep learning course, where we really want students to understand what's happening under the hood and not just mechanically executing commands in PyTorch and trying to figure out what's happening. Yeah.
Great, thank you so much. Kevin, what, if anything, would you add to that?
I don't have a lot to add except to say, my course, I teach the supervised learning course and unsupervised learning course, and those are introductions to machine learning. As Paramveer said, it's Python based. We focus on scikit-learn as our generic machine learning library. It doesn't support deep learning. It has some you can build small neural net with it, but it doesn't support deep learning, which is fine because we don't teach that in my course. But and we also we try to keep the course up to date, and we do use other libraries outside of the core ones if a new technique comes along that we feel is important students know about, and so we add that to the framework. Example would be the dimensionality reduction technique UMAP, which isn't part of scikit-learn but has libraries that support it and they're well documented and so on. So things like that. So we try to keep the curriculum up to date as well, because as we all know, it's a very fast moving field.
Yeah, it absolutely is. And I think one of the specific advantages of the MADS program is that the vast majority of our courses are 1 credit, 1 month courses. So we iterate on our courses every 3 months. And so we can adapt very quickly in instances where we see something has become popular and or used for a specific purpose that we want to implement in our curriculum. And we don't have to necessarily wait, right, a year or years to do that. So Kevin, you and I have talked a lot about success in the MADS degree. And in fact, we're deeply committed to ensuring that everyone that comes to us is successful. And again, I think one of the things that distinguishes us from other programs is we don't require a technical background to be a participant in our degree program. In fact, we want people to come with non-technical backgrounds as much as we want people to come with technical backgrounds. But that being said, what are some of the things that you think can prepare our applicants well for their participation in the program, in addition to the kinds of things that we teach them along the way?
I think just getting some sort of baseline experience with Python, just sort of getting used to the idea of taking a problem, breaking it down into logical steps, and then writing the code that solves each of those steps. Frankly, for a lot of the assignments, like in my course, for example, you're not writing hundreds of lines of code to solve these problems. But you have to know what are the right 3 or 4 lines of code to sort of walk through and get the solution to each of the steps. So it's not like you have to be a Python wizard at all to take these courses. It's more of a mindset of being curious, of developing a mindset of thinking logically about how to break problems down into steps, and practicing that on just simple coding problems will help a lot with that thinking. I guess that would be the main thing I would say.
That's great, Kevin. I appreciate you mentioning that we are, again, a Python-based program, but that we're not looking for computer scientists to practice data science, right? We're really looking to use Python in a very specific way. At the same time, we do value that computational thinking, for example, right? That we would expect students to both gain some exposure in before they join us. Then of course they'll get a lot of additional exposure while they're with us. So they're doing things like coding efficiently. They're using the best methods to code for solving specific data science problems.
That's right. And we put a lot of effort as a team, as the MADS team, everybody, to try to structure the program in a way that does scaffold the math, statistics, and things you need. So we've worked really hard. We've gotten together as instructors and staff to figure out, okay, well, I might say, I need to teach these concepts in my course. Can we make sure that that we have covered, in the earlier courses and things like that? So it requires a degree of coordination between the courses that you might not normally see in a regular residential program. And it's been a really interesting process. And I think, we've definitely, as Amy said, we iterate our courses all the time. So in fact, just this week, I have a meeting to go over the last iteration of the machine learning course and talk about what went great, what needs to be changed. And we do that for every single iteration. So, and we get a lot of input from students, by the way. We had some great input over the summer, for example, that I got about just some suggestions for how to improve some things, and we listen and we take action. So that's the great thing about the program. Everybody's heavily invested in making it as best it can be, and that's one of the things I love about teaching it.
Yeah, I agree. I think the investment is really high, and you can certainly see that in the way that our faculty approach how they teach and how they iterate in courses. Elle, you and I have also had some great discussion about, for example, how math shows up in the MADS degree. And that's one of the things that people are perhaps often the most freaked out about, if they don't have a math background, but we know it's really important for success in the program. Can you talk a little bit about, and you of course have some great experience in math as it relates to data science, even before joining us. So can you talk a little bit about how you see the math show up and how we're preparing people for the math in the data science degree?
Yeah, so there's a tremendous variety of math backgrounds coming in. There are people that are, quite comfortable with math, and there are people that haven't touched it in maybe 15 or more years. But I think that in data science, there are several kinds of math, and a lot of people who say, oh, I'm not a math person, there actually is a kind of math maybe that they're quite, that they really take to or find kind of natural for them. And a lot of what we do, we have, a math methods course, and, there is a statistics prerequisite when coming into the program for, I think it's an online stats class, which Amy can confirm if that is correct. And a lot of it is really done through coding, which is quite different than the kind of math that you might have had to do in high school, where you would, write out algebra and have to solve for X. A lot of what we do is math that is, it's computations that are performed in a, just through a computer, basically. And so it's not that, the computer is entirely like your calculator and that's it. There's quite a lot of work that has to go into interpreting and making decisions. But, a lot of those decisions come down to sometimes a judgment call. There's a lot of choices that you have to make as a data scientist, like how many clusters do I want? How many dimensions do I want to reduce my data to? And, we kind of learn more conventions about that, but also when do you decide to go against a convention? When do you make a judgment call to follow, which of these many possible rules will you use? And so the math is, it's quite different than a lot of the ways that people have been exposed to math, at least through my American lens of what a public school system is like. It's quite different from that.
So Amy, I just wanted to add something. I just wanted to add to what Kevin and Elle said. And I said that I totally agree with their characterization of maths in our program. And especially it's like maths, but applied to a purpose for data science. It's not just like theorem proving or abstract things that we teach you, but and there's like a tremendous amount of scaffolding that happens, for students who don't have like math backgrounds or those who come from arts background, let's say, for example. But the biggest ingredient I feel that we want all of our students to possess is like a passion and a strong will to become a strong data scientist. So that's the important ingredient that we all need, that you should have a passion to be like a data scientist, a rigorous data scientist. If you have that, we will train you end to end to achieve that purpose. Yeah, thanks.
Thank you, Paramveer. I think that's incredibly well put. And so really we're saying that you will likely come in with some Python skill, right? We have an expectation that you're at a skill level of kind of an introduction to the fundamentals of Python. So a little bit more than just the sheer introduction to Python, but not enough where, for example, again, you would be considered, for example, a software developer or computer scientist, but some good fundamentals of Python, some good fundamentals of statistics, and then we do the rest. Now, we did make an intentional decision when we started plotting the trajectory for the maths program to teach in Python. And yet, Paramveer, as you know, we often do get questions about R, right? So why are we not using R, for example? Why are all of our courses in Python? And I was just hoping that you could speak a little bit to our motivation for the use of Python, or what using Python for teaching data science does for us.
Yeah. So I think like in today's day and age, it's always helpful to be multilingual in terms of programming languages, and, for example, I also know R, in addition to Python. And, when I was in my undergrad, we used to code in MATLAB and Java and C++. So it's always good to be a polyglot in, so to say, in programming languages. It really helps. But the way that the pace of things are going in data science, like Python has become like the de facto standard for many of the data science application. And it abstracts away so much of the complexity that you would have faced, like if you were to code in R or C++ and so on. And another reason that we chose Python over R is because there are so many libraries that are just built for Python. So the ecosystem that's there is much stronger than for R or like for some other programming languages. And especially for deep learning, there are frameworks like, TensorFlow, PyTorch, MXNet by Amazon, and there's so many others that are there that you could just plug and play, so to say, right? And now R is a fantastic programming language too, but it's geared more towards statisticians or, like people who are more in social sciences, but less so for, for many of the data science applications that you would use in your day-to-day life as a data scientist.
Great, thank you. I think that was a really well put explanation of why we picked Python. It does not exclude, of course, someone from learning additional languages, including R, but that we did make a strategic choice kind of in our program and based on our faculty's expertise in Python to make this a Python-based program. So as our applicants are learning Python, as they're navigating programming, some of them, of course, many of them are brand new to it. Inevitably, we get the questions about, will I fit? So Kevin, can you talk a little bit about folks that have non-technical backgrounds? If you have a bachelor's in business administration, an English degree, you've been in finance, or perhaps you're working in nonprofit organizations, how much or little do you see all of those folks in the MADS program?
Those are some of, we see a lot of students like that in the program, and some of those are my favorite examples. I mean, there was a student who had a background in 19th century German literature, and she had no programming experience whatsoever. And to see students like that be able to do things like what she wanted to do was go do a study of women authors in the 19th century who actually published as men, and so she was able to crawl the websites from these obscure archives in Germany, and then actually do linguistic analysis and to answer the questions that mattered to her, and that was just really cool. And that's great seeing that as someone as an instructor in the program. And so I think we work really hard. We understand that the people come from different backgrounds, and if needed, the instructors during these courses will make extra time if necessary. I have a bunch of slots of one-on-one time that if you feel like you need some more explanation of a particular thing, more than happy to set up some one-on-one time to discuss it. And we also have, in my course, in unsupervised learning, We have 3 different office hours that happen during the week. They're my office hours, which are actually starting in a few minutes. And then we have 2 other graduate assistants. So there's plenty of like huge amount of support, both scheduled and if necessary, unscheduled, you know, to go through homework and to talk about concepts and things like that. So we really, this is the farthest thing that you could imagine from, you know, a bunch of videos plus Google. The instructors, the staff, everybody is very involved and very active, you know, in talking to students throughout the course.
Thank you, Kevin. And I appreciate your point that we wanted to deliver a 100% online degree in the University of Michigan School of Information because we realized that we could never have the kind of learning community where everyone that wants to come to the University of Michigan can, right? Like there's lots of folks, particularly those, again, that are working full-time jobs, that are living around the world, that have familial responsibilities or responsibilities to their community, who can't, for example, pack up and move to Ann Arbor for a few years as much as we might want them to. And so this gave us that opportunity to do it, but not in a way that sacrifices, for example, our commitment to building and achieving a really strong and supportive community where people feel like they're getting a lot of that engagement and interaction, as much so, but just in a different way than they would if they were to come to one of our residential programs. So I have a somewhat niche question, but I'm just interested to see if anyone knows or has any insight to offer. So I'm just going to ask anyone. Have any of you, or do you work with the IARPA, the Intelligence Advanced Research Projects activity? Does that sound familiar to anyone?
Yeah, it does to me, and I could, but I don't.
Okay, there you go. Thank you, Kevin. Okay. So we've got a couple of additional interesting questions that I would actually like to ask all 3 of you. So I am going to ask the first one, and then I'm hoping that each of you can just talk for a few minutes about your opinion and kind of perspective, and then I'll ask the next one. And again, I'd love to hear what each of you have to say. So one is, do you see a decline in the demand for this field in the next 10 to 20 years? So in other words, we've talked a lot about how data science is a growing industry. There's good evidence that supports that fact. Will that change? Is there a future state where data science careers wane? So I'd love to get each of your perspectives on that. And Elle, let's start with you.
Yeah, so I do think that in the fields of, you know, machine learning, there has been like an AI winter, you know, in the past where, you know, we get really excited about something and then it turns out not to be returning companies quite as much on their investment as they thought, and then they scale it back a little bit. So I do see that there can be cycles, but I guess what I see about data science that will not go away is that managing data science projects is something that requires incredible ability to deal with complexity, right? Like you have really complex models, you have really complex data sets, and you need complicated computational systems to manage, you know, all of those. And with companies that work on the scale of very large data, I mean, that's just a huge technical and organizational challenge. And I mean, yeah, if all data science is you try a bunch of models in scikit-learn and you look for the one that has the best result, then that could go away because we could automate that. But really managing the full scale and complexity of any kind of applied data science project is something that I don't see automatable anytime soon.
Thank you, Elle. Paramveer.
Thanks, Amy, for the great question. And so the short answer is no. I do not see a decline in the data science jobs in the next 10, 20 years. And the main reason for that is, let's see, why did data science become such a hot field, you know, that there's such a staggering growth in that? And the main reason for that is the growth in data, right? So the main reason that has spurred the growth of deep learning models or like general machine learning models over the last 20 years is the rise in data. And we are increasingly collecting more and more fine-grained data than we were 10 years ago. And I only see it going upwards. You know, of course, there would be privacy regulations and so on. And what that calls for is that there would be new model architectures that we would have to build. You know, the current extant set of models that we want to that we use right now, they might not be valid in the next 10, 20 years. But data science as a field is definitely like on an upward trajectory, because the data is, of course, continuously increasing, and so is the compute resources. One of the main reasons that some of these this the data science revolution over the last 10, 12 years has been like increase in compute power. So these days, my laptop has more compute power than a supercomputer in the 1980s or early 90s, right? So it just goes on to show how much processing power there is at our disposal to crunch those numbers on those minute by minute, moment by moment data sets that your Apple Watch or your Alexa is gathering about you, right? So I think it's only, my hunch is it's on an upward trajectory, and it's going to stay that way because of these two reasons. But the models and the tools that we use, they will evolve, right? So just like, maybe there would be a more meta level language than Python, which would come around in the next 10, 12 years, so that we don't even have to specify the nitty gritty details of the models as we do now. And that's where our maths program is so unique, because we teach you about the fundamentals, and we do not tie you like we give to a specific model or a class of models, but we give you a broad overview of even like things like causal inference and AI ethics and so on, so that when that shift happens to the new set of models, that you are well prepared to be like a strong data scientist even in that realm. Thanks.
Thank you. And Kevin?
Well, I don't have a lot to add to what Elle and Paramveer said. I guess our hope is that the program, our aim is the program will continue to evolve as data science evolves. We all, instructors in the program, we all do research. We all have worked or are working closely with companies. We stay in touch with kind of what's going on, and we look ahead. So, I just to say, I echo what Paramveer said as well. There'll be sort of changes in the level of abstraction. Like you don't have to sort of code in thousands of lines of C++ anymore to do to deep learning. You can write something in a few lines of code, but the implications of that algorithm can be profound, and so it's going to take new. There are going to be jobs that don't exist today that will exist in 5 years, and that's already happening. There are jobs that exist today that didn't exist 5 years ago, and there are jobs at the involving especially communication between people who have the ability to communicate between highly technical teams and highly business-focused teams. When I talk to people at major tech companies, so I ask them, what should we be teaching our students? Of course, there are the usual technical things, but the other thing that comes about is they say communication. We see a lot of students who can code up things, make an algorithm run, but the people who can communicate, about what's going on, understand the assumptions that go into that from a human perspective, those kinds of things are becoming incredibly important. And I don't think that's going to change at all. So yeah, I think the program will evolve as data science evolves, and I think the focus on just not going beyond just the computer science aspects to the broader implications is another thing that the program, I think, is a strength of the program.
I agree. And in fact, when we talk about evolution, it brings me to my next question. And the reason I want each of you to answer this question is because you may define this question in a different way. So in other words, the question is, what is the most advanced subject in the maths degree? So Kevin, this time I'm going to start with you. What would you say is the answer to that question? I'm so curious.
Well, what the most advanced, I would say that's very interesting. So we go into things like the EM algorithm, which on the surface seems very simple, but then as you look deeper, there's some sort of more profound structure to that space. I would say we get into support vector machines, which are kind of classifier, are based on convex optimization algorithm. We don't go into great detail on the convex optimization part, although we do talk about it. That's probably one of the more sort of sophisticated things that we it's always an interesting balance between treating something as a black box, and you have knobs in the box, and you have to understand how the knobs work to actually opening up the cover of the engine and actually looking to see, you know, exactly what's going on. So we try to find a level of abstraction that's sort of in between, that gives insight into why these algorithms behave the way they do and how they can be controlled, but not get into too much of the technical detail. Again, it's the applied nature of the program. So yeah, I would say, you know, sort vector machines, expectation maximization algorithm. Those are the kinds of things I think are probably the more advanced in my course.
Thank you. Elle, what about for you? How would you define advanced?
Super, super hard to say for sure. I would say, I mean, I had students in the Capstone last summer that did reinforcement learning, and that got pretty advanced really fast. But that wasn't part of the MADS curriculum. That was something that they were more poised to dive into, you know, because of what they had done before. In terms of advanced, that's really like systematized and part of our curriculum, I think that causal inference is you have to have really subtle and clear ways of thinking about what statistical significance means, you know, and how to construct models, you know, and what are the relationships between the things in your model. And I feel like that is something that it gets deep, and it can be unexpectedly deep. And, you know, in the students, I think before and after some of them take causal inference, I see a big difference in the way that they're able to conceptualize, you know, statistical testing and what kind of inferences that, you know, just everything about how they speak about statistics seems to kind of transform around that class. You know, I've been very impressed, having absolutely nothing to do with this course. I'm very impressed by, you know, the kind of nuance that students have when they come out of it.
I love you mentioning causal inference, and in particular, the way in which we are introducing statistics in the degree, including our experiment design and analysis course and our causal inference course. Reinforcement learning is on the docket, in fact, and will launch in December. So that is exciting too. But I think, again, you know, thinking about all of the different aspects of data science and how important the statistics shows up in data science is really critical, in addition to the great work we're doing in machine learning. And then finally, Paramveer, what would you say?
Yeah, again, like that's a very loaded question, Amy. It's a very hard question to answer. But I would mostly say like some of the things that have already been said. So I think like reinforcement learning would be the most methodologically advanced thing. And like in the stuff that we cover in our deep learning course, that's also advanced. And the stuff that Kevin talked about, like, you know, the EM algorithm, like, which is the most cited statistics paper of all times, you know, probably the most important algorithm that we all know, came out in the late 70s. So it's also much more nuanced and like difficult to understand, but also very, very important. So other than that, I think like, you know, causal inference, you know, is not typically covered in most data science courses, because data science is about predictive modeling for most other schools, but not for us. For us, like causal inference and experiment design are also part of data science, because so what these courses teach you is like how to intervene, right? So all other courses are, here is some data, fit some model, make some predictions. But those two courses are how you intervene. And as we know, like this year's Nobel Prize in economics went to some people who worked on causal inference and experiment design, right? So it's like big implications. And we've also integrated into causal into our MATS program. And a reason which makes those like the causal inference much harder than some of our machine learning courses is that in our machine learning courses, like there are methods that once you understand them, that they might look easy. But in causal inference, the methods, that the assumptions that they rely on, the assumptions are untestable. So that's why it's so hard. And you have to think about in terms of counterfactuals. What would have happened if I were to spend an extra year in school? That's a much harder question than learning about an algorithm, about convolutional neural networks, which you can go step by step and try to figure out how it works. So it's difficult, but it's a different kind of difficulty. You know, like you have to think about like, what would have happened had I done this, right? So I think like it's a little bit of everything that Kevin and Elle said, and like, you know, a few other things that, you know, like some interesting tidbits in our curriculum that are hard, so to say. Yeah.
Thank you. That was a fantastic answer. And thank you for amusing me with that question. That's one of the benefits of being the facilitators. You get to ask these hard questions and then defer to these great experts to answer them. So we've come to our hour, and there are still a few questions in the chat, a couple of which were fairly specific. So I do welcome you to email us at umsi.mads@umich.edu if there are any additional questions that we did not get to in this hour. In just 1 minute, so just in 10 seconds, could each of you just answer what I think will be a far easier question, and that is, simply as we wrap up and people are considering whether or not to hit that submit button, why should they do it? So in other words, why should they apply to MADS? Paramveer, why?
Yes, I think like it's a no-brainer to apply to our MADS program, and we look forward to seeing your applications. But like it's the most diverse program that, as I said, like teaches you things about causal inference and experiment design also, which you will not find in other courses. And even on the predictive modeling side, we go to as advanced topics as reinforcement learning and deep learning, which are not part of many other data science courses that you could find online. And then another thing is, like, as our dean says, that like although it's an online program, but you get all the perks like alumni benefits and so on as you would get for a residential course, except that you don't get tickets to attend the Michigan football games in person because you are not here in person. So a long story short, I would say just hit that submit button now, and we look forward to seeing your applications.
Thank you. Elle?
I think that data science is, it's just one of my favorite places to help people launch their careers, because it's a growing field. There are great salaries and there's great problems. Like it's really cool that it's an amazing space to work, where like you can have, intellectual fulfillment, you can have personal fulfillment by working on problems that are close to your own, sense of mission. And there's just so many opportunities. So it can really be, a huge impact on your life to move into a career that affords you those opportunities and pays you well. And there are many ways to get into data science, but I think this is an efficient one, a pretty cost-effective one. And, as Paramveer said, that the network and the community is just one of the coolest parts. So, we'd love to get to meet you, and, just really looking forward to seeing some applications.
Thank you so much. And finally, Kevin.
Well, I think everybody on the MADS team has worked really hard to create a program that welcomes the diversity of students that we see, a fantastic cohort of students that you'll be part of. I think we've really done a pretty good job of hitting that sweet spot of theory and practice, of choosing things that are important in real world scenarios, while also giving you the fundamental tools, the fundamental concepts. When the current tools change, you'll still be able to master the next tools because you understand the basic concepts. And I think the final thing is just that everybody on the MADS team, all the staff, the instructors, everybody has invested a lot in the success of the program, and we are all invested in your success as well.
Thank you so much. So again, thank you so much for joining us today. We are very eager to see your submitted applications and to welcome you into the MADS program starting in January 2022. If you had a question that we didn't get to, I welcome you to email us at umsi.mads@umich.edu. And as always, go blue.